Hi everyone and welcome back to my bench. As you can see, today I have quite a lot of components because we're gonna be building 6 air quality sensors to be plugged into the Pulse.eco platform. For those of you that don't know, Pulse.eco is a crowdsourced platform that gathers environmental data like PM10 pollution, PM2.5 pollution, noise, temperature, humidity, and atmospheric pressure that is then shown within the app or within the appropriate website. And I've already built a sensor for the platform that I'm housing at my home. You can check that video up here. But today, with the help of some friends that donated the parts for another 6 sensors, I'm gonna build them completely and then we're gonna distribute the sensors throughout the city, so hopefully we get a better coverage in some of the areas where we don't have any of the sensors. Each of the sensors work with the Nova SDS011 PM particle sensor, which is an optical sensor that has a fan that gathers air, measures the number of particles in the air, and then it outputs the air from this outlet here, and it looks something like this, and they will all be controlled by an Node MCU board. You've seen these before because we are using them constantly in all of our project, and the temperature, humidity, and pressure will be measured by the BME680 sensor that we have here on this breakout, and the noise measurement will be done by a sound sensor, by microphone like this, that will measure the ambient noise and output that through the analog output. For the output of the microphone we need 2 resistors, and I'm also gonna use a PCB to hold everything to it so it's safely mounted within the enclosure. As per some of the previous project, we're gonna use electrical boxes to house everything in, and we're gonna need to drill some holes within them so that the sensors are able to gather air from the outside and also be able to measure the outside temperature. And before we continue, let me thank today's sponsor, which is PCBWay. With cutting-edge technology, fast turnaround times, and unbeatable prices, PCBWay is your one-stop shop for PCBs, prototyping, and assembly services. At the moment, they are celebrating their 10th anniversary, where you can win decent coupons, participate in lucky draws, get an exclusive online badge, participate in badge charity sales, and you can even mark your place on the map. Trust the experts, trusted by engineers worldwide. Visit PCBWay.com today and take your project to the next level. All of the Node MCUs and microphones already have pin headers on them, but the BME680 don't, so I'm gonna start the project by soldering the headers on all of them, and then we'll need to figure out the placement of the components on the PCB. So let's start with the soldering. In order to figure out the layout of components on the prototyping board, I'm going to consult the construction manual that you're going to find in the video description for the Wi-Fi version of the sensor that I'm building. And we can see here that the BME680 connects to pins D1 and D2, except for the 3.3 volts and ground. And that's on the right side of the Node MCU. So I'm thinking about placing the Node MCU at the bottom like this. Then we're gonna have the BME sensor somewhere to the right, something like this. We'll probably need to go a bit to the left, so yeah, that way we have enough space, and we can run the connection wire on the side, and the SDS011 will connect to pin D5 and D6, and we'll use software serial, I guess. So that will leave us to have some sort of a connection cable. Some of the sensors came with a cable like this that can be plugged into one side of the board, and that breaks the E4 connection that we need, and we can solder the other side to the board directly. And finally, The microphone needs to connect to the analog 0 input on the Node MCU. That's on the far top there, and we can have the microphone soldered like that. And the two resistors that are required, the 100K and 220K, can be soldered on the board directly in between the required pins. I think that this will work, so let's start soldering. Since I don't want the Node MCU board to sit flush with the PCB underneath, to have some clearance for the antenna and also for the connector that we need to plug in later on to power the whole device, I'm using two pin headers to slightly raise the PCB off my desk, and then I'm letting the pins rest on the desk. So I'm gonna solder just one of the pins like this from the top, if I can reach it, and then we're gonna solder the rest from the underside. It's a bit tricky, but let's see if we can manage it. Okay, maybe. Yeah, so that's holding just enough so I can flip it and solder the rest from the back. To get the fumes away from me when soldering, I'm using my fumes extractor that I've built in a previous video. Link will be up here. Okay, so now that we have all of the controllers soldered, next is to solder the BME 680, and I'm gonna solder it right here on the right, so because we can connect it closely there, and if I flip it, then this barely fits here, but I'm gonna solder just one of the pins now. Okay, and I'm gonna press it a bit so it stays nicely in place, and now we can solder the rest of the pins. And it's now rinse and repeat for all of the controllers. Now for the microphones, we're gonna do something similar as we did with the BME 680, but the problem is that the pins are facing the wrong way. So if we solder it directly, then this will stick out very far out and won't fit in the case. So I used pliers to bend the pins inward, and this last one, which is the digital out, which we won't use, is slightly bent, so I could use it just as a support here, and the rest of the three pins will be soldered there. Now let's try it out. I need to find something that will serve as a support from the bottom. Okay. Again, I'm just soldering one of the pins, making sure that the placement is okay, and then I'm gonna solder the rest. Okay, so that should be fine. And this one I'm gonna try to solder just for mechanical support. And I have all of the microphones soldered on, but I was supposed to add these resistors before I soldered the microphone. They're connected between 3.3 and the analog 0 input on the Node MCU. I think I'll be still able to manage it, but it would have been much easier if I could fit them before fitting the microphone. But it is what it is. Now let's try to fit them the best we could. Let's see what the spacing would be. Let's try something like this. That's a bit too much, so we need to go a bit closer. And that will do, although not perfect, but will do. And the last thing that we need to connect to the boards is the SDS011 particle sensor, and a few of them came with this ribbon cable that I'm gonna reuse and cut off to be soldered directly to the PCB. And I'm thinking that it would be best if I solder that from the back, because that way we're gonna have nice and tidy setup in the box. So let's try and do that. We need to keep in mind that the power supply is connected to the 5 volt instead of the 3.3 volts as the BME 680 and the sound sensor. So we need to figure out how we can route everything to the V-in pin. And let's confirm that we've soldered everything as expected. So connects to D5, and it does. RX connects to D6, and it does. Ground connects to ground, and 5 volts connect to VIN. Okay, we have the connections. Now we need to do the same on all of the rest. Okay, so I did 2 of the SDS011 sensors, but I realized that I haven't connected the BME 680 and the sound sensor. So on this one, I'm gonna connect those first to see if any of these wires will be a problem, and then we'll see how it goes. If we continue to do the wiring of the other 2 sensors first, or if we continue to wire the SDS011. And here is now the device with the full wiring. That was definitely easier to add the wiring to the rest of the components on the PCB first and then connect to the SDS011 sensor. So going further, I'm gonna do that for all of the rest. Now it's rinse and repeat for 3 more times. And just like that, we now have all of these sensors soldered together, and I verified all of the connections with my multimeter. Now, next up is to flash them with the right software and then to prepare the enclosures. To flash the firmware, we're gonna use a micro USB cable to connect to the Node MCU. And we're gonna use a program called Node MCU Pi Flasher. The Node MCU should appear here, so let's check within the device manager. Let's reload that. Yes, so COM4. We're gonna choose the binary that you could download from the official website with the instructions. And for the settings, we need to choose 115200 for the baud rate, and flash mode should be quad IO and erase flash no. So let's try and flash the Node MCU. Okay, that seems to be working. It says it's writing the firmware. Let's wait for it to finish. Okay, so hash of data verified, staying in boot mode, the firmware successfully flashed, unplugged, replugged the reset the device to switch back to normal boot mode. Okay, so let's unplug it, and we go not plug it again. We see a blue LED, and to verify that it's actually working, we need to see if we're gonna see a Wi-Fi being created so we can connect to it. And yeah, if you can see it here, you would see that you got a Wi-Fi called Pulse.eco sensor, and this is what we want. We need to connect to that to configure it, but we'll leave that for the end. Now, as with the other steps, we need to make sure we repeat all of the steps as before. So I'm gonna reload, select the COM port. I'm gonna leave all of the settings exactly the same and choose to flash it. And we're done. Now for the enclosures, the idea is that the sensor will sit something like this inside the box. So we have the fan on the bottom and the outlet on the top, and then the controller board will sit on top of it. So we need to make some holes on the enclosure just to have the right airflow and to have the right connection for the cable. So we'll drill one hole here on the right. I'm gonna get the marker to mark everything out. And with the enclosure ready, we now have everything that we need to power on the sensor, and I have this one powered on. Here you could see that there is a blue light that lights up, and that indicates that the sensor now emits its own Wi-Fi, and I'm gonna connect to it. So it's called Pulse.eco sensor, and there will be a number on it, and so it connected to the device, but it cannot provide internet. If we go to a browser, and based on the configuration, we need to go to this IP. Let's paste it here. And this will give you a configuration page where you will need to enter the device key that you're gonna get when you register the device on the website. I'm going to show you that in just a minute, and then you need to show it your SSID and password for the Wi-Fi so you configure it. On the web, once you log in to the platform for your own city, then you have a button to add your device, and within that page you will need to select the type of sensor that you've built, and this is the Wi-Fi sensor version 2 that we worked on. You need to figure out a device ID based on the parameters that are given here, so it can be easily identified within the city. You need to select the location where it's added and also provide some description and comment on any additional information. Once you do this, you're gonna get the device key that you need to enter within the device configuration, and after that the device will start working and start emitting the data. So with that, I will end the video right here and provide you an update once we distribute the sensors and once we mount it throughout the city. And if you like this video, then give it a thumbs up below. Make sure to subscribe so you don't miss any of the future videos, and I will see you all in the next one. Cheers!